Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass and I am with Open Systems Media and Embedded Computing Design. This week, my guest on the podcast is Dermot O'Shea, and he is the CEO of Taoglas. And before we get started, Dermot, I want to make sure the audience is familiar with Taoglas. So what is it that you guys do?
So Taoglas, we are a global antenna solutions provider. So we design and manufacture antennas for wireless communications.
Perfect. I have found over the years that antennas are sort of like this black art where people have like no idea how antennas work, and for the most part, they don't care. The embedded system developer just gets his design from somebody like you and plops on his board, and it usually works. Do you find that that's the case, that people don't really understand what you guys do, and in most cases they don't really care?
So I think first of all, yeah, we love it that everybody thinks it's really complicated and it's black magic because it makes us feel special and makes the customer feel like they need us. But in all seriousness, yeah, I think that was the attitude maybe more 10, 20 years ago, but people are definitely wiser because they've learned their lessons from having that attitude that I can, maybe have the antenna as an afterthought. If you look at any wireless product these days, there's a lot of antennas in there, and it's getting more and more complicated. So it's quite a lot of real estate actually on your PCB is if you look at how much space antennas take up. So you really need to plan them at the very beginning of the project, and think about your installation, where the device is going to live, what kind of certification you need. And I think a lot of our customers would have learned the hard way. I've had some issues with antenna design and integration and selection, etc.
Yeah, you actually hit on the topic that I'd really like to talk about. Well, if you open up some sort of mobile device today, there are so many different media that it has to be able to talk to and talk to securely. And bandwidths are super high now, frequencies are super high now. How do you ensure that all that stuff works the way it's supposed to?
So yeah, you have to keep testing at various stages of the design. So, if you look even on our website, we have what's called an antenna integrator that allows anybody to go onto the website and select certain types of antennas and then input their individual PCB size. And then within 24 hours, it will return to you a simulated performance based on your own individual parameters. So that's kind of phase one. Phase two then we just make rough kind of prototypes that would mimic the shape of what the final device would look like. Then the customer makes some prototype hardware, we check it again, and then as the product is about to come to its final state, we check it when it's turned on and when it's connected in the chamber, like to a call box in a real life scenario. So we're always testing in very controlled, repeatable environments. And we would test, like you said, at every frequency in every scenario. It depends on, how much testing the customer wants to do. And then an important question we always ask is what type of certification do you need? Like, for example, in the United States, the operators here, AT&T, Verizon, and T-Mobile, they all have specific standards of performance that your device has to reach. So it has to be able to, for example, send with a certain amount of power, and it needs to be able to receive a very weak signal. And they test that. And the antenna is a really important part of those tests. So, that's how we make sure that you're in the right place before you go for production.
That's really interesting. So from a design perspective, does the engineer need to do any design, or is he basically handing over his board layout to you and saying, okay, what do I do?
Yeah, we'll do it all. So if you look at Apple, Samsung, these guys that do the cell phones, they have a lot of antenna engineers, a lot of antenna anechoic test chambers. But most companies don't have that, right? They don't have in-house antenna expertise. They're not going to invest in all the equipment that you need for the design and testing. So we basically do all of that for them. The tools that I mentioned, we have also cable builders and antenna builders where customers can do a lot of, customization online. But when it comes to like consultation and testing, we do all that for the customer. So we have labs in each location. We've 8 locations across the world, 3 here in the US. And we would encourage customers to send us their like design files at the beginning. So we help with the antenna selection and integration. And then when the devices are ready, we get the device in-house and we start testing. We have a lot of prototype equipment in each lab as well. So we will actually, make PCBs or 3D print parts that look like their design files in real life so that we can give the customer basically good kind of overview of what their performance is going to look like. Because as we said, the antennas being such a demand on the space, every customer wants it cheaper, faster, and better. But we have to show them that, the performance sacrifices that will happen the smaller and smaller you go. So that's usually an important exercise, for example.
So is that just a trade-off where you say, well, how well do you want this to work? And based on the size, the bigger we can make it, the better your device is going to work?
For sure, like, the bigger the better. If you have no size restriction, you probably don't need us, right? You can take products off the shelf from our website and go with that. A
Mm-hmm.
lot of the times we're dealing with more challenging scenarios if it's coming in-house. Like it's, there's a lot of metal in the installation, it's going in the engine of a car, or it's a very small device that's going on the body or something like that. So if it's kind of a more traditional design, we can probably just help with advice and some part numbers. So yeah, it's always a trade-off. And a lot of the time these days we're dealing with, isolation and interference. So if there's like even with a MIMO system, I've seen it so many times, like with a box where you have all the antennas on the outside of the box all beside each other. Like that's not a good situation for isolation and interference. It probably almost, you know, defies the purpose of having a MIMO system where you've spent a lot of money developing
Mm-hmm.
a MIMO system, but now you've really brought the performance down by putting all the antennas beside each other in the same orientation. So when we're designing, we make sure the antennas are not that they're like as far away as possible from each other, that's obvious, but that they're orientated in ways where isolation is optimized. And if we do that, then we can minimize interference between the antennas and increase throughput and keep the user experience at a maximum.
Now you mentioned that you want to get into these designs at the very early stages, but it seems like everybody wants to have their part done first. You have to pick your processor first. You have to pick your operating system first. Yeah, if it's a mobile device, you need to make sure you have the right room for the battery. Now I have to do the antenna part first. What's really first?
Yeah, well, for us, it's definitely the antenna, right? That's all we
Of
think. That's
course.
all we might not be we might not be much, but we're all we think about. You know what I mean? So, like obviously, it's only at the start of the hardware, and it's only like initial con. You don't have to do very much on the antenna design. You just basically create. You could even do it on the back of a napkin. You know what I mean? At the
Mm-hmm.
bar, you could literally like just draw out your device and say, "Here's where we need antennas." And here's how much space we would like you to leave for optimal performance. And then we don't need to talk to you again maybe until you have some hardware prototypes ready. So it's not that there's much to be done at the start, but it's
Mm-hmm.
definitely an important thought in the initial kind of layout and how much space you're going to need.
And how often do you come into a design where the potential customer says, I can't get this thing to work, help us?
I Not as much now. I think that's how we built our brand for sure. Like 22 years ago, it was all putting out fires, and we built a reputation up with the operators and the likes where they would see issues like that, and we would have to come in and give some bad news to a customer, like you need to grow your device or you need to start your antenna design again. But these days, I feel like there's a lot more experience in our market.
Mm-hmm.
Most customers are not doing their first connected device anymore. So they know they have, a better design process in place. And they'll check with all the people you just mentioned, but at least we're in the list now. And, the operators have told us in the past that at the end of the day, one of the most common points of failure for certification on the hardware side is the antenna. So they have
Hmm.
definitely seen a lot of pain and suffering caused by bad antenna selection and integration. So they do recommend to the customers as well that they talk to us early. And the same goes with the like cellular module vendors and GNSS module vendors. They'll always say, you're going to need an antenna with that, and you need to check the selection and integration early on. So we're all singing from the same hymn sheet, really, all the kind of partners in the ecosystem. So that really helps eliminate those scenarios. So I have to say we don't see it as much. It's probably gone from 80-20 of putting out fires to the other way around. I think 80% of the customers these days are better prepared.
Okay, one more question for you. You mentioned certification. Is it possible that I could pass for one geography and not pass for someplace else?
Definitely, yeah. Like there's very little certification or testing required in certain countries. So like a lot of the smaller countries, um, even, I would say US is the strictest, and then Japan, and then Europe and Australia. The rest you can just get SIM cards. Do you know what I mean? For
Hmm.
example, and
Yep.
and and do your thing. And the only way they'll come after you is if you're causing issues on the network.
Hmm.
So it kind of goes like that. But, even if you do get the SIM cards, at the end of the day, the certification process, kind of forces you into a very good discipline of making sure the device is going to work at all frequencies in all scenarios, even in fringe areas of the network. And I think that's good. In my opinion, that's been good practice for all customers, because it means in the field and throughout the lifetime of the device, you're not going to have those kind of issues, and it gives you the peace of mind that you have followed that right process, especially, everyone has issues on devices, and if it's firmware updates or security like you
Hmm.
mentioned. At least when you're diagnosing these things that it's not a performance issue, or oh, did the operator do something and now they've changed the frequency and I'm not good on this band, or oh, did I ever check that it works in Arizona near the border, etc. So it just gives you that peace of mind as well. And I've seen people that have gone through the process just inherently have been more successful in the market with their devices.
Very good. Thank you very much, Dermot. I love talking about this stuff because, as you know, I alluded to in the beginning, this is the analog black art that people I always thought were afraid of, but apparently they're not as afraid as they used to be, but they need to be very careful.
Yeah, that's it. No, it's been a pleasure, Rich. Thanks for having me. Appreciate it.
That was Dermot O'Shea. He is the CEO of Taoglas, and I am Rich Nass with Open Systems Media.